Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we are solving problem 4.20. So, the statement is in a centrifugal compressor, the air is compressed through a pressure ratio of 4 to 1. Pressure ratio of 4 to 1 mean that P2 divided by P1 is equal to 4 mean that P2 is 4 times greater than P1. If if P1 is equal to P, then P2 is equal to 4P. And the temperature of the air increased by a factor of 1.65. T2 divided by T1 is equal to 1.65. It means that if T1 is equal to T, so T2 is equal to 1.65 T. Show that the process is irreversible. Number 1, process is irreversible. Number 2, calculate the change of entropy per kilogram of air. Calculate change of entropy. And assume the process is adiabatic and sketch the process on a TS diagram. And assumption is process is adiabatic. Process is adiabatic. So first we draw TS diagram, temperature in degree centigrade, and entropy in kilojoule per kilogram per Kelvin. Now P1 and P2 are given to us. This is P1 is equal to P. So P2 is 4 times of P1. So P2 is equal to 4P. And temperature, let this is 0.1. So temperature 8.1 T1 is equal to T. So this is temperature T2. T2 is equal to 1.65 into T1, 1.65 times of T1. So this is 0.1 and this is 0.2. So this is the process from 1 to 2. So first we have to show that process is irreversible. So the process will be irreversible. First we have to show that the process is irreversible. The process will be irreversible if process is adiabatic. Process is adiabatic and entropy increases. Entropy increases. So we suppose we have to show that entropy S2 is greater than S1. Then process will be irreversible. For that we consider a point on constant pressure line with same entropy as S1. This is, we name this S2S. We suppose a point S2s on constant pressure line, constant pressure line, P2 is equal to 4p, such that S2s is equal to S1 of the same entropy of S1. So if entropy at point 2 is more than 2s, it means that the entropy at point 2 will be more than S1 and the process will be irreversible. So for that we find T2s divided by T1. So we find that if T2 is greater than T2s, then entropy at point 2 will be greater than entropy at point 2s and the process will be irreversible. So for that we find T2s. So T2s divided by T1 is equal to, formula for this is for the same pressure ratio, for the same pressure ratio, T2s divided by T1 is equal to P2 divided by P1 whole gamma minus 1 divided by gamma, which is equal to P2 divided by P1 is equal to 4, gamma minus 1 divided by gamma, 1.4 minus 1 divided by 1.4. So this implies that T2s divided by T1 is equal to, this is simple calculation, find 1.4 minus 1 is equal to 0.4, 0.4 divided by 1.4 is equal to 0.2857, and then 4 power 0.2857 is equal to 1.486. Now is T2 divided by T1, which is equal to 1.65, which is equal to 1.65 is greater than T2s divided by T1, which is equal to 1.486. So it means that T2 is greater than T2s, and this is uh, this is point 2s and this is point 2. From graph it is clear that T2 is greater than T2 is S2 is greater than S2s. S2 is greater than S2s. So it means that entropy at T2 and is greater than entropy at T2s, and it is clear, and it is clear from the TS diagram as well, from the TS diagram as well, that S2 is greater than S2s. So as the process is adiabatic and entropy increases, so the process is irreversible. For reversible process, entropy will be constant. Now we are finding S2 minus S1. So for S2 minus S1, first we find T2s divided by T2 divided by T2s. So we can find T2 divided by T2s by the ratio T2 divided by T1 multiply by T1 divided by T2s, which is equal to T2 divided by T1 is given to us, and I can write this as 1 over T2s divided by T1, and T2s by T1 is already found by us. So T2 divided by T1 is 1 over 6, 1.65 minus multiply by 1 divided by T2s divided by T1. So T2s divided by T1 is 1.486. So this is simple calculation. If we calculate this value, the entropy, the ratio T2 divided by T2 is will be equal to 1.11. Now S2 minus S1, this is equal to S2 minus S2S, because S1 is equal to S2S from TS diagram, and you can check here. This is T1 and this is so S1 is equal to S. This is point 1 and this is point 2S. So entropy at point 1 is equal to entropy at point 2S, and we are taking S2S instead of 1 because this is constant pressure process from 2 to 2S. This is constant pressure process and we can easily find change in entropy. Therefore we are using point 2S instead of point 1. So S2 minus 2 S2, this is constant pressure process, and for constant pressure process entropy is equal to Cp natural log of T2 T2 divided by T2S. So S2 minus S1 is equal to, the value of Cp per year is 1.005 kilojoule per kilogram per Kelvin into natural log of T2 divided by T2S. So T2 divided by T2S is equal to 1.11. Now take natural log of 1.11 and multiply by 1.005. So S2 minus S1 will be equal to 0.105 kilojoule per kilogram per Kelvin. And positive sign mean that entropy increases. And this is the end of the problem. And for more lecture, please like and subscribe my YouTube channel and share with your friends. Thank you.